Question 1, we want to work out 8.46 divided by 0.15. Now the first thing to note here is that if we multiply each of these numbers by 100, then this is the same as 846 divided by 15. And we can do that because if we think of this as a fraction, 8.46 over 0.15, as long as you multiply the numerator and denominator by the same thing, you're not changing the value. And so this is the same as 846 divided by 15. Now you use the method of division that you're happy with, but this is a non-calculator paper, so I'm going to look at using the bus stop method. So I want how many 15s go into 846. Of course none go into 8. How many 15s in 84? If I need to, I could write out my 15 times table, but I know that 6 15s are going to be 90 because 2 15s are going to be 30. And so 5 15s must go into 84, and that will actually, 5 times 15 is 75, so that will leave a remainder of 9. And then I can say how many 15s go into 96? Well, as I've said, I know 6 will go into 90, and that will leave 6 left over. So what I'd need to do on my bus stop here is add a decimal point and a 0 to continue this. So now I can say how many 15s go into 60, and since 2 15s are 30, then 4 go into 60. And so my final answer is 56.4. Question 2. I want to work out 7 3/8 minus 2 1/2, giving my answer as a mixed number. Now, you can deal with the whole numbers and then deal with the fractions and bring your answers together. I actually like to just turn these both into top-heavy improper fractions. And so in order to do that, you take the whole number multiplied by the denominator, so 7 times 8, which is 56, and then add the numerator, which is 59. And so I'll have 59/8 minus 2 times 2 plus 1, so that's 5/2. Now that I've got them as mixed numbers, I can see here that 2 goes into 8. In fact, 4 2's go into 8. So if I multiply numerator and denominator here by 4, I get the equivalent fraction. So 5/2 is equivalent to 20/8. Now the denominators are the same, I can subtract them. So 59 take away 20 is 39/8. Now my answer needs to be as a mixed number. And so I need to say how many 8s go into 39? Well, 2 8s are 16, 4 8s are 32. And so there would be 4 8s in 39 with 7 left over. And so that would be 4 7/8. Final answer, 4 7/8. Question 3. A cube has a total surface area of 150 centimeter squares. Work out the volume of the cube. Now, the surface area of a cube is the sum of its 6 faces. So the first thing I want to do is divide 150 by 6 to work out the area of each individual face. And so 150 divided by 6 is 25. And so I know each face of my cube is 25, and because it's a cube, I know the face is a square. And so if this area is 25, what I want to do is find the length, which of course is going to be equal to the width as it's a square. And so what squared is 25? 5 squared is 25. And so if the length of this cube is 5, then the volume of this cube is 5 times 5 times 5, or 5 cubed, and so the volume is 125 centimeters cubed. Question 4. The table shows information about the daily rainfall in a town for 60 days. I want to draw a frequency polygon for this information. And my axes are drawn for me with frequency on the y-axis and rainfall along the x-axis. Now, a frequency polygon, we plot the midpoint of the group to the frequency. And so the midpoint of 0 to 5 is 2.5. Now it's quite nice, we've got the axes drawn for us here, and so halfway between 0 and 5, there's 10 squares between, so that's 5 squares will be exactly halfway, and I want to plot a frequency of 8, and the scale is nice on this y-axis as well. Each little square is worth 1, so I want to go to 2.5 and up 8 squares for my first point. My second point is halfway between 5 and 10, and so again I can go to my axes halfway between 5 and 10 and go up to 24 and put my second point. Then between 10 and 15 I need to go up to 13, 15 and 20 I need to go up to 11, and then 20 and 25 in the middle I need to go up to 4. Now when we join these on a frequency polygon, we use straight lines, and we do not need to join it to these axes. And so plotting our straight lines completes our frequency polygon. Question 5. We have a set here containing 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A is the set of odd numbers and B is the set of square numbers. Part A, I want to complete the Venn diagram for this information. And so what I need to do to be able to put the numbers inside each of these sets, I need to know which of these numbers are odd numbers and which are square numbers. And so if I list the odd numbers first of all, that's all the numbers which aren't even. And so 1, 3, 5, 7, and 9 are my odd numbers. All of the square numbers within this set here, I've got 1 squared is 1, 2 squared is 4, and 3 squared is 9. So I've got 1, 4, and 9. Now the best way to complete a Venn diagram is to first look for the numbers which go in this middle section. So that is all the numbers that are both odd and square. And I can see I've got 2 here. I've got 1 and 9, which is in both of those sets. Now I can fill in the rest of the circles. So if I look at set B, there's only one number now that isn't included, and that's the number 4. So that is the only square number which is not odd. And I can now place my other odd numbers which are not square numbers into this circle A. So I've got 3, 5, and 7. Now the complete set is this box. So there are some numbers which have not yet been listed, and so they need to go inside this box. So the remaining numbers in my set are 2, 6, 8, and 10. A number is chosen at random from the universal set. Find the probability that this number is in the set not B. And so the set that are B are 1, 9, and 4. So there are 3 numbers in B, which means there are 7 numbers which are not in B. And those 7 numbers are out of our total 10. And so the probability that the number is not in B is 7 over 10. Question 6. The scatter graph shows information about the ages and weights of some babies. We've got weight on the y-axis in kilograms and age along the x-axis in months. Part A, describe the relationship between the age and the weight of the babies. And so what we're looking at here is that as the age increases, the weight also increases. And so you may also be thinking positive correlation. And so yes, as age increases, weight increases. And you may also write down positive correlation in order to pick up this 1 mark. Another baby has a weight of 5.8 kilograms. And then part B, using the scatter graph, find an estimate for the age of this baby. Now, when using a scatter graph to find an estimate, it's a good idea to have a line of best fit. Now, the line of best fit just has to be a straight line which generally follows the trend of the data. So I've plot my line here, but your line may be slightly different, and there will be a range of accepted answers due to this fact. And so on my graph, if I want to estimate the age of a baby that is 5.8 kilograms, I'm going to find 5.8 on my y-axis. So in between 4 and 6, in the middle here is 5, which means each of these small squares is worth 0.2 kilograms. And so I need to go up 4 to get to 5.8. I'll draw a horizontal line across from that point to my line of best fit, and then from that point a vertical line down, and then I can read off the x-axis my approximate age, and so for me that is 4 months. Question 7. The price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. Now, since this is a non-calculator paper, I'm going to look to find each percentage worth. So this 20% increase is worth £240. And so 20% is worth 240. Now, if I'm happy here, I could multiply this up by 5 to get 100%, but since this is a non-calculator paper, slightly safer route, if I divide these values by 2, then I know 10% is the same as £120. And the price of the holiday before the increase is 100%. So the price of the holiday is 10 times these values, so 100% of the cost is £1,200. And this is slightly nicer to multiply this by 10 than this by 5. It is up to you how you get there, but I can write down that the price of the holiday was £1,200. Question 8. The diagram shows a solid cylinder on a horizontal floor. We're given this formula: pressure is equal to force divided by area. The cylinder is 40 centimeters tall. So this cylinder has a volume of 1,200 centimeter cubed. The height is 40 centimeters. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor due to the cylinder. Our pressure formula involves force and area. Now at the moment we don't have the area of this circle that's making contact with the floor. But since this is a cylinder, the volume of this cylinder is the area of that circle multiplied by the height. And so I can find the area by taking that volume and dividing it by the height. And so the area of the circle is 1,200 divided by 40, which is 30 centimeters squares. Now I know the area to be 30. I can look at finding the pressure by putting in the values. I know the force is 90 newtons, and I've just found the area to be 30. So the pressure is 90 divided by 30, which is 3. Question 9. Use these graphs to solve the simultaneous equations 2 minus 2y is equal to x and 2y is equal to 3x minus 22. Well, we have each of these lines drawn on this set of axes here, and so solving them is to find the point where they cross. And so I need to read off this coordinate here, and so along the x-axis I count up to 6, and the y-axis we go down to -2. And so the coordinate of this point is 6 minus 2, which means the solutions to my simultaneous equations are x is equal to 6 and y is equal to -2. Question 10. Here is a pentagon. Angle AED is 4 times the angle ABC. Work out the size of angle AED, and you must show all of your working. Now, since angle AED is a multiple of ABC, I'm going to label ABC as x, which means I can label AED as 4x. Now, the sum of angles inside a pentagon must add up to 540 degrees. Now, there are a couple of different ways you can learn this number. A nice way I find is if I were to draw a line from, let's say, A to C, then I would have a triangle and a quadrilateral. And I know the angles in a quadrilateral add up to 360, and the angles in the triangle add up to 180. So the sum of angles in the pentagon must add up to 540. But there are other formula you can learn for this fact. But knowing they must add up to 540, I can write the following. 120 plus 4x plus 135 plus 110 plus x is 540. And if I simplify this, that is 365 plus 5x is equal to 540. Subtract 365 means that 5x is equal to 175, and then dividing by 5, x is equal to 35. Now the angle I want is AED, and AED is 4x, so that's 4 lots of 35, which is 140 degrees. Question 11. Write 6x to the power 5 y cubed all squared divided by 3x squared y to the power 7 times 4x y to the minus 3 in the form a x to the power b y to the power c, where a, b and c are integers. And so we need to break this down. Let's look at the numerator. So everything inside this bracket is being squared. And so when we have a number, the number 6 is simply going to be squared itself, so that will be 36. When we have something to the power raised to another power, we multiply those numbers together. So this will be x to the power 10, and this will be y to the power 6. And so on the numerator, we've got 36 x to the power 10, y to the power 6. Now on the denominator, dealing with the numbers first, we've got 3 times 4, which is 12. X squared multiplied by x. When we multiply, we add our indices, and so x is to the power 1, which we don't typically write, so that's 2 add 1, that means we've got x cubed, and then y to the power 7 times y to the power minus 3, again we add these powers, 7 plus minus 3 is the same as 7 minus 3, which is 4. Now we've simplified the numerator and the denominator, we can deal with the number, the x and the y component. So firstly, 36 divided by 12 is going to be 3. When we divide our powers, we subtract them. So x to the power 10 divided by x to the power 3 is 10 subtract 3, which is x to the power 7. And then y to the power 6 divided by y to the power 4 is 6 subtract 4, which is 2. And so our final answer is 3x to the power 7 y squared. Question 12. Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. Find the probability that Martha will lose at least one game. Well, if Martha loses at least one game, then she either wins then loses, or she loses then wins, or loses both. And so ultimately it's that she doesn't win both games. And so the simplest way to find the answer here is to find the probability that she wins both games and subtract that from 1. Now on a tree diagram, we can find the probability she wins both by multiplying the probabilities together. So the probability she wins the first and the second game is 5/8 times 2/9, which is 10/72, or 10 over 72. And so the rest of these probabilities will add up to 1 minus this 10 over 72. And 1 minus 10 over 72 is 62 over 72. And so the probability that Martha will lose at least one game is 62 over 72. Question 13. Y is directly proportional to x. Y is 24 when x is 1.5. Work out the value of y when x is equal to 5. Now, if y is directly proportional to x, we can write this, that y is proportional to x. When we replace a proportionality sign, we replace it with equals some constant. So y is equal to some constant multiplied by x. We can find this constant because we've been told that y is 24 when x is 1.5. So if I substitute in those values, 24 is equal to 1.5k. Dividing by 1.5 gives me a k value of 16, which means that instead of y is equal to kx, I can write y is equal to 16x. And so if I want to find y when x is 5, I can substitute 5 into this, and so y is 16 times 5, which is 80. Question 14. Part A, write 1/16 in the form 4 to the power n, where n is an integer. So firstly, let's look at 16. Hopefully we recognise 16 as a square number. In fact, it is 4 squared. So we can write this as 1 over 4 squared. And now what we need to know is that 1 over 4 squared is the same as 4 to the power minus 2. And so this can be written as 4 to the minus 2. Work out the value of 8 to the power 5/3 minus 9 to the power 3/2. Now, when you have a fractional power, the number is to the root of the denominator and then to the power of the numerator. And so this is the same as the cube root of 8 to the power 5 and the square root of 9 to the power 3. We can find the cube root of 8. Cube root of 8 is 2, and the square root of 9 is 3. So this is the same as 2 to the power 5 minus 3 cubed. 2 to the power 5, that's 2 times 2 times 2 times 2 times 2 is 32. Subtract 3 times 3 times 3, which is 27. And this gives us a value of 5. Question 15. The equation of line L1 is y is equal to 2x minus 5, and the equation of line L2 is 6y plus kx minus 12 is equal to 0. L1 is perpendicular to L2. Find the value of k, and you must show all your working. Well, the equation of line L1 is already in the form y equals mx plus c, and so I know the gradient of that line to be 2. So what I would like to do is find, in terms of k, the gradient of line L2, because since they are perpendicular, I know that the product of the two gradients will be minus 1. And so let's start by rearranging L2. So I want this in the form y equals mx plus c. So if I subtract kx and add 12 to both sides, then 6y is equal to minus kx plus 12. And now if I divide by 6, y is equal to minus k over 6x plus 2. Now the bit I'm interested in is the gradient. As I've said, since they are perpendicular, then the gradient of L1 multiplied by the gradient of L2 should equal minus 1. And so dividing both sides by 2, minus k over 6 is equal to minus a half. Multiply through by minus 6, then k must equal 3. Question 16. Here is a sphere. Surface area of a sphere is 4 pi r squared. 3/8 of the surface area of this sphere is 75 pi centimeter squared. Find the diameter of the sphere. Give your answer in the form a root b, where a is an integer and b is a prime number. Okay, so let's start with this 3/8 of the sphere is 75 pi, because ideally since I know the surface area of the whole sphere to be 4 pi r squared, I'd like the full surface area of this sphere. And so since this is a non-calculator question, I think if I write down that 3/8 is 75 pi, I can find the value of 1/8, dividing these by 3 to be 25 pi. And so now multiplying that by 8, I get the full surface area of my sphere to be 200 pi centimeter squares. Now I can use this in my surface area of a sphere equation. And so my total surface area, 200 pi, is equal to 4 pi r squared. I can divide both sides here by 4 pi, and so 50 is equal to r squared, which means r is the square root of 50. Now, the square root of 50 is the same as the square root of 25 times 2, which is root 25 times root 2. Root 25 is 5. So my radius is 5 root 2. Now, I'm trying to find the diameter of my sphere. The diameter is 2 times the radius, which means my diameter is 2 lots of 5 root 2, which is 10 root 2. Question 17, make x the subject of the formula y is equal to 4 lots of 2x minus 7 over 5x plus 3. And so my goal here is to get x on its own, typically on the left-hand side of this equation. So let's start by getting rid of this fraction by multiplying both sides by 5x plus 3. And so multiplying by 5x plus 3, on the left-hand side I've got y lots of 5x plus 3, and that's now equal on the right-hand side, I just have my 4 lots of 2x minus 7. Let's expand these brackets. So on the first bracket here, that's y times 5x is 5xy, plus y times 3, 3y, and that's equal to 4 lots of 2x, which is 8x, and then 4 times minus 7 is minus 28. Now what I want is my x's on the left-hand side. So if I subtract 8x from both sides and subtract 3y from both sides, then on the left-hand side I've got 5xy minus 8x, and on the right-hand side I've got minus 28 minus 3y. Now with all my x's on the left-hand side here, I can factorize. So I can take the factor of x out. So this is x lots of 5y minus 8, which is equal to my minus 28 minus 3y. And now finally, to write x is equal to something in terms of y, I want to divide by this 5y minus 8. And so my x value is equal to minus 28 minus 3y divided by 5y minus 8. Question 18. 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of 480 pence. The cost of 1 kilogram of carrots to the cost of 1 kilogram of tomatoes is 5 to 9. And I want to work out the cost of 1 kilogram of carrots and the cost of 1 kilogram of tomatoes. Now I'm going to be setting up some equations to deal with this, and so I'm going to use the value of C for carrots and T for tomatoes. And so initially this 7 of carrots and 5 of tomatoes costing 480, I'm going to use that line to write this equation. 7 carrots plus 5 tomatoes is equal to 480. Now I'm going to use this ratio, that if the cost of carrots to tomatoes is 5 to 9, what that means is that 5 times the cost of tomatoes is equal to 9 times the cost of carrots. This is probably the toughest step because a lot of people would want to say 9 tomatoes to 5 carrots because of the way the ratio is written. But using equivalent fractions for ratio, this is C over T is equal to 5 over 9. Using this, I can substitute into this top equation. So that's 7c plus 9c is equal to 480. That is 16c is equal to 480. Dividing by 16, that means the cost of a carrot is 30 pence, or rather the cost of 1 kilogram of carrots is 30 pence. And then substituting that into my first equation here, 7 lots of the cost of carrots, which I now know to be 30, is 210 plus 5 times the cost of tomatoes is 480. Subtracting the 210 means that 5 kilograms of tomatoes are 270 pence. Dividing by 5, that means that kilogram of tomatoes is 54 pence. So carrots I have 30 pence and tomatoes I have 54 pence. Question 19. The menu in a restaurant has starters, main courses and desserts. There are 5 starters, there are 12 main courses, and there are X desserts. There are 420 different ways to choose 1 starter, 1 main course and 1 dessert. Work out the value of X. Well, in this choice style question, then to get the total number of choices, we multiply the values together. So if there are 5 starters, 12 mains and X desserts, we multiply the 3 together to get the total number of combinations. And so I've got 5 times 12 times X is equal to 420. This is 60X is equal to 420. Dividing 3 by 60 gives me that there must be 7 choices for dessert. Question 20. For x greater than or equal to 0, the functions f and g are such that f of x is 3x plus 4 and g of x is root x plus 2 over 5. Part A, find the inverse function of x, that's g to the minus 1. Now, typically to find this, I will start by writing g of x as equal to y. So I'll let y equal root x plus 2 over 5. The reason I'm doing this is it's just a little bit easier to rearrange, because what I'm looking for is x in terms of y, which will then become my inverse function x, and I'll replace my y values with x. And so let's rearrange this to get x in terms of y. So multiplying both sides by 5, 5y then is equal to root x plus 2. Subtracting 2 from both sides gives me 5y minus 2 is equal to root x. And so squaring both sides, x is equal to 5y minus 2 all squared. Now I have it in the form x equals. This x becomes my g to the minus 1x, and I replace that y with an x to write g to the minus 1 of x is 5x minus 2 all squared. Part B, solve g f of x is equal to 3. So this is composite functions. So this is putting f into the function g. And so if I substitute f of x in place of x in g of x, that is the root of 3x plus 4, or plus 2 divided by 5, is going to equal 3. And so this is the equation I want to solve. Multiply them through by 5, I get root 3x plus 4 plus 2 is equal to 15. Subtracting 2, I get the square root of 3x plus 4 is equal to 13. Squaring both sides now, 3x plus 4 is equal to 169. Subtracting 4 from both sides gives me that 3x is equal to 165. And finally, dividing by 3 gives me an x value of 55. Question 21. A, B and D are points on a circle with centre O. CDE is the tangent to the circle at D. Work out the size of angle ADC, writing down any circle theorems you use. Okay, so I want this angle here, but let's look at what we've got. Well, firstly, I can find this angle here because this angle on the circumference is subtended by B and D, and B and D subtend the centre with a value of 64. And so this angle DAB must be 32, since angles subtended at the centre are twice the angle at the circumference. Now I can use the fact that angles in a triangle add up to 180 degrees in order to find this angle here, which is going to then be 180 take away 32 take away 51, which is 97 degrees. Now, since this angle is 97 degrees, the angle in this triangle, which is vertically opposite it, is also 97 degrees, since vertically opposite angles are equal. And now I can use angles in a triangle again to find this angle here. So 180 subtract 97 and subtract 64 gives me a value of 19 degrees. And now I can finally find my angle ADC, because a tangent will meet the radius of a circle at 90 degrees. And so 90 take away 19 is 71 degrees. So my angle ADC is 71 degrees. Question 22. A, B, C, D, E, F, G, H is a cuboid. A to F is 6.8 centimeters, and F to C, which is the diagonal through this cuboid, is 13.6 centimeters. I want to find the size of the angle between FC and the plane ABCD. And so let's draw a triangle FAC. And so FAC, the angle I want is this angle here I'm calling X. That is the angle between the diagonal FC and then the plane ABCD. Now I know FA to be 6.8 centimeters, and I'm also told that FC is 13.6. So I have two sides, and I want an angle on a right-angled triangle. And so I'm going to look, this side here is opposite my angle, and this is my hypotenuse. And when I have O and H, I can use my SO triangle from SOHCAHTOA, which is to say that sine of my angle X is equal to my opposite, 6.8, divided by my hypotenuse, 13.6. Now, this doesn't look particularly nice, especially on a non-calculator paper, until we note that 6.8 over 13.6 is a half. And so sine to the minus 1 of a half is 30 degrees. And this is one of the values that you need to know. I've included the table here of other values you will need to know before you head into your non-calculator exam. Question 23. I want to write 3 root 3 over 4 minus root 3 minus 2 over root 3 in the form a root 3 plus b over c, where a, b and c are integers. Now, since the denominators of these two fractions are different, I can't yet subtract them, but if I multiply numerator and denominator here by root 3 and numerator and denominator here by 4 minus root 3, then I will have a common denominator. And so doing that, that's 3 root 3 over 4 minus root 3 times root 3 over root 3 minus 2 over root 3, and that's times 4 minus root 3 over 4 minus root 3. What I want to do now is simplify this. So 3 root 3 times root 3 is 9, and that's minus 2 times 4, which is 8, and then minus 2 times minus root 3 is plus 2 root 3. And my denominator is root 3 lots of 4 minus root 3. So 4 times root 3 is 4 root 3, and then minus root 3 times root 3 is minus 3. So this is looking a little bit nicer, but we can simplify the top here. 9 take away 8 is 1 plus 2 root 3 over 4 root 3 minus 3. Now, we do not want a surd on the denominator of our fraction. And so since we have 4 root 3 minus 3 on the denominator, it's common practice to rationalize this denominator by multiplying by 4 root 3 plus 3 over 4 root 3 plus 3. So now, simplifying the numerator, 1 times 4 root 3 plus 1 times 3 plus 2 root 3 times 4 root 3, that's 8 times 3, which is 24, plus 2 root 3 times 3 plus 6 root 3, and that's over the denominator, 4 root 3 times 4 root 3, which is 48, minus 3 times 3, which is 9. And that's because when we choose this value to rationalize the denominator, when we have 4 root 3 times 3, we are subtracting 3 times 4 root 3. So those terms will cancel. Simplifying this again now, on the numerator, 4 root 3 plus 6 root 3 is 10 root 3, 3 plus 24 is 27, and on the denominator, 48 subtract 9 is 39. And so my final answer is 10 root 3 plus 27 over 39. Question 24. Find the set of possible values of x for which 4x squared minus 25 is less than 0 and 12 minus 5x minus 3x squared is greater than 0. And you must show all your working. So firstly, let's look at this one on the left-hand side, 4x squared minus 25. Now the key here is to note that this is a difference of square. And so this factorizes to 2x plus 5 and 2x minus 5. Now if we were to consider this equal to 0, then the two values we would get are x is 5 over 2 and x is minus 5 over 2. And so with a sketch here of our quadratic, it cuts the axis at minus 5 over 2 and 5 over 2. Since I want the values that are less than 0, I want this part of the curve here, which are the values bound between minus 5 over 2 and 5 over 2. This 12 minus 5x minus 3x squared, this factorizes to 4 minus 3x, lots of x plus 3. This then, again with another quadratic sketch, would give me crossing values of minus 3 and 4/3. Now this time the sketch is upside down because if we notice we've got a negative x squared. So in this sketch we go downwards, and since I want the values now greater than 0, I want the values bound by minus 3 and 4/3. But my answer needs to be the set of values for which this is true and this is true. And so in terms of my lower limit, if it needs to be greater than minus 3 but also greater than minus 5 over 2, then it must be greater than minus 5 over 2 since this is the higher of these two values. And since it has to be less than 5 over 2 and less than 4/3, then ultimately it must be less than 4/3, as this is the lower value of those two. We can also see this visually if we have a quick sketch of the inequalities, so being between minus 2.5 and 2.5, and also in between minus 3 and 1 1/3, then values we are interested in is the overlap of these two inequalities. And so my final answer is that x is between minus 5 over 2 and 4/3.